Today we're going to talk about functions. So first we have to talk about function form. I know when first you're introduced to functions, we always write them as y equals some function, but you can replace the y with f of x. It means basically the same thing. This does not mean f times x. You say f of x. And it's just the rule we do to each input to get an output. And it's like y, but it's more complicated, more convenient notation for complicated operations. It's also nice because you don't just use f, you can use any letter. We usually start with f for function, but then we'll have g of x, h of x, some random letter of x. And it's nice because then the functions, different functions have names, and so you can refer to different functions by name, and you'll know which one you're talking about. Okay, so if g of x equals x squared plus 2, g of 3 is what? Well, all this means is what's inside the parentheses goes where the x is. So I'm going to draw some parentheses, and I've got that squared plus 2. What goes inside the parentheses? 3. So g of 3 is equal to 3 squared plus 2. 3 squared is 9 plus 2 is 11. Now what if x plus 1 is inside the parentheses? Same thing. I just write out x squared plus 2, but instead of x I put parentheses. And whatever's inside these parentheses goes inside those ones. So x plus 1. X plus 1 squared is x squared plus 2x plus 1. And I still have that plus 2. So when I combine my like terms, I get x squared plus 2x plus 3. Alrighty, what I would like you to do yourself is if f of x is x minus 4, I would like you to find f of 7, and I would like you to find f of x plus 1, and then we're going to move on. Something else you might not have encountered before are piecewise functions. And piecewise functions are pretty easy. They might be new. So basically, it just means that the function is defined in pieces. This particular function has 2 pieces. Some of them have a zillion pieces, but we're just talking about a nice simple 2-piece function. And what it says, when this is true, you follow this rule. And when this is true, you follow this rule. So the way I would read this is say f of x equals x for or when x is less than 2. And f of x equals 2x minus 2 for or when, whichever word you prefer, x is greater than or equal to 2. So I'm going to look at this piece first. The line is y equals x, but I have to stop at 2. In fact, since x is strictly less than 2, I'm not allowed to get to 2. Just like on an inequality, the way I show that is with an open circle. So I'm going to draw the line y equals x. Pretend my line is straight, and I'm going to slow down here because when I get to x equals 2, I need to put an open circle. Okay, that's my first piece of my piecewise function. Stick an arrow on there to show it goes on forever. Next, my second piece, 2x minus 2. This starts when x is greater than or equal to 2. So I'm going to plug in 2. 2 times 2 is 4, minus 2 is 2. So my point is 2, 2. Hey, look. In this case, these two happen to hook up together. So I'm going to go ahead and fill in this dot. And then the slope is 2x. Sorry, the slope is 2. 2x means the slope is 2. So I'm going to go up 2 over 1, 2 over 1, up 2 over 1, and draw this line. You'll notice that the slopes of my 2 lines are different. This has a slope of 1, and this piece has a slope of 2. It just happens that these 2 pieces connected. In your DIY, I don't think the pieces do connect. So just remember to put an open circle on the strictly less or greater than one, and a closed circle on the end that has the equals sign as part of your inequality. By the way, little side note, when you can, since these hooked up or connected, I can trace this function without lifting my pen up from the paper. That's called continuous. So it turns out that this function is continuous even though it's a piecewise defined function. Go ahead and graph this piecewise defined function for yourself. Alrighty, operations with functions. First, I'm just going to define f of x to be x squared minus 1 and g of x to be x minus 1. F plus g of x just means you take f of x and you add it to g of x. So f of x is x squared minus 1 plus g of x is x minus 1. X squared, let's see, I only have one set of like terms. So let's see, x squared is its own thing, x, but negative 1 and negative 1 makes a negative 2. Okay? F minus g of x just means that I subtract the 2. So I have x squared minus 1 minus, I'm going to have to worry about distributing a negative, so I'm going to put some parentheses here. Minus this x minus 1. Alright, I need to distribute the negative, so negative x, the opposite of a negative is a positive, so plus 1. Okay, so x squared is its own thing, minus x. Negative 1 and positive 1 cancels out, and so all we've got is x squared minus x. Next, we have f times g of x. So I'm just going to take f of x, multiply it by g of x. X squared minus 1 times x minus 1. Okay, it's like going trick-or-treating. I don't know if you guys have done that. Every kid visits every house. So x squared times x is x cubed. X squared times negative 1 is negative x squared. Now x squared's visited all of those. Now it's negative 1's turn. Negative 1 times x is negative x. And negative 1 times negative 1 is positive 1. We don't have any like terms, so I'm just going to go ahead and be done with that one. Last but not least, we have f divided by g of x. That's just f of x divided by g of x. So I've got x squared minus 1 divided by x minus 1. And then if I can, I need to simplify it. I just happened to pick polynomials that are going to simplify. So x squared minus 1 is a difference of squares. That's x plus 1 times x minus 1 divided by x minus 1. So that cancels out, and we're left with x plus 1. For your DIY, if you could please use h of x equals 3x minus 1 and k of x equals negative 2x plus 5. Find h of x minus k of x, or I'm sorry, h minus k of x, which is h of x minus k of x. Do remember to distribute your negative sign. And also find h times k of x.